All right. So let's now move way, way, way down in the hierarchy of computational problems. Is everybody following so far?
Yeah.
Excellent. Let's come back down. There is a picture of my father. There's a picture of me. My father was one of who sort of defined polynomial time, right? So these are the problems that can be solved in polynomial time, right? Like n squared or n to the millionth time. And the question is, can all reasonable problems be solved in polynomial time? Or are there reasonable problems that industry would love to solve, really practical problems that industry would love to solve that can't be solved in polynomial time, right? That was the question that my father was asking about the time I was being born. All right.
Is this P versus NP?
Yes.
Like,
This
yeah.
is P. That was my father posed the question, P versus NP. In fact, if you go to his house in Waterloo, he has a big rock in front that looks like a gravestone, and it asks the question, does P equal NP? Now,
What do
most
you,
P. What?
well, what do you think? Do you think P equals NP?
I was about to say that
Oh,
most people in the world believe that they're not equal. Or if they are equal, then we'll still never be able to prove it. But my father thinks they're equal. But anyway, let's make sure other people know what we're talking about. All right, so that's what we're going to define now. So here, let's come up with some polytime problems. All right, the first polytime problem is, suppose the input gives you a circuit. And what is a circuit? It's the same as what we had the polynomial, but the difference is the inputs are binary, right? Each variable is not an arbitrary integer, but each input is yes or no. And then the gates, instead of them being times and plus, the gates will be and and or. And we're asking, we plug in true, false, right? The inputs are 0, 1, yes, no, true, false. You plug in, if I give you an assignment, then you plug them in and you percolate out, you get an answer, true or false, right? And so that's the computational question, is I give you a circuit and I give you an input that sets the variables to true or false, and we ask, does this input satisfy the circuit? Is the output true, right? And is this a computable problem? Yeah, definitely. What's the algorithm? Well, you just plug in, you have a circuit, and you have true, false, you plug them in, you percolate the true, false down to the bottom, you find out whether the answer is true or false, right? In this case, it was false. Everybody follow that problem? Right? And circuits, you think, circuits are a very practical thing, right? Because what I'm holding in my lap this very minute is a laptop, and what is it? It's a big and or not circuit, right? So we care about circuits. All right, so now I'm going to tell you a problem that we believe can't be done in polytime, right? I'm kind of lying to you. Here I'm calling it a non-polytime algorithm, right? But the person who was just talking, what he basically asked is, do I believe that this problem can be done in polytime, right? The question is, I'm claiming here it can't be done in polytime, but it's still open whether it can be or not. But here's the intuition why it can't be, all right? So here's the problem, is I don't tell you the input, right? I just tell you the circuit. And I ask, does there exist an input that satisfies the circuit, right? So this problem is called, is C the circuit? Is the C circuit satisfiable? Does there exist an input that satisfies it, right? Everybody get the question, right? So what would an algorithm for it be? An algorithm would be to search all possible inputs, right? The input says true, false on the various variables, right? Now, when the inputs were integers, there was an infinite search space, right? So we couldn't try them all. But now we have a finite search space. In fact, how big is it? If we have n variables, then there's 2 choices for the first variable and 2 for the second and 2 for the third. So the total number of inputs that we could have is 2 to the n, right? So in 2 to the n time, I can certainly try them all and tell you whether or not the circuit is satisfiable, right? But that's not poly time, that's exponential time, right? So this problem, does there exist an input that satisfies this circuit? I can certainly do it in exponential time. I just try all inputs, right? So then the question is, can I do it in poly time? And as said, the belief is you can't. But there is a class called non-deterministic poly time. It's called NP, right? And where's the non-determinism come from, right? Well, we're taking 2001, right, this very second. So you know about non-determinism when it came to, we did non-deterministic finite automatas, right? Where you have sort of a fairy godmother helping you, right? And if the answer is a yes, then there exists a path through the through the finite automata that leads to a yes. But if the answer is no, then there's not a path, right? That was non-determinism. Well, here's the same. If the answer to this, right, then there exists an I, there exists a witness, there exists a proof, there exists a solution, that if the fairy godmother gives it to you, she gives you an I, then you can quickly plug it into the circuit and convince yourself that it's satisfiable, right? But if you don't have a fairy godmother, then you might have to search through all possible assignments, and that would take you exponential time, right? Are people kind of getting this problem? Any questions?
So is it kind of saying, like, if you get lucky, and you just hit the right solution, then it can be done in poly time?
If you get lucky, right. In fact, in 1090, we did an algorithm called Davis-Putnam, which says, I want to know whether this circuit is satisfiable. So I'm going to start with one of the variables, and I'm going to try setting it to true and simplify it. I'm going to try setting it to false and simplify. And you build up this truth table of it's a tree. You try setting X to be true and set it to be false. And then you set Y to be true and false. And hopefully you get lucky and you find a solution. All right. Everybody understand these those are our classes.
Jeff,
Yeah.
we can just plug it in and run it in the machine. Is that fine? Like, if we just have a circuit, then we can just make an algorithm in, I don't know, Verilog and run
Yeah.
it
So
to
here's
get
the
output.
point. If I give you a circuit and somehow you get an assignment to that circuit, maybe you're lucky, maybe you meditated and had divine inspiration, maybe you have a fairy godmother who gives it to you, maybe you're just insightful. Somehow, if you get an assignment, then you can convince the entire world that the circuit is satisfiable. Why? Because the entire world can plug your assignment in to the circuit and say, yes, this assignment satisfies the circuit, right? But if I have this circuit out there and I don't have an assignment, then I don't know how to know whether it's satisfiable without trying them all, right? Any questions about the class, this problem? All right, so now Cook came along in 71 and he proved that actually the satisfying circuit problem is complete for the class, which means that if you could solve it, you could solve everybody in the class, right? So somehow SAT is the hardest problem from this class, right? So we no longer care about little weird problems, because if you could solve SAT, you can solve them all. But we don't think you can solve them all, so we don't think you can solve SAT. Well, my father thinks you can solve them all. I mean, for example, if you could solve SAT, then you could solve them all. Well, one of them is breaking cryptography, right? If what's cryptography is, I have basically a circuit which says if you plug in my password, then you can get it. You can steal all my money, right? And if I tell you my password, or you guess my password, or fairy godmother gives me your password, you can log in and steal all my money. But if you don't have my password, then you have to try all passwords, right? And that takes exponential time. But if NP equals P, then in some ways it's good because industry can solve these problems quickly. But in some ways it's bad because there'll be no more cryptography. There'll be no more privacy, right? The only way you can have privacy would be to lock yourself in the room and cut all the wires, right? But as soon as you connect to the internet, there would be no more privacy.